Hey peeps, welcome back to my channel and to a new episode of our SwiftUI series. In this episode, we are going to learn how to implement a dynamic list. And what I mean by that is we have a list of Pokemons, even with their types. And as soon as we click the add button, we are adding random Pokemons to our list. Now there are static lists and dynamic lists, as you can see here, and we are covering both as well as the identifiable protocol. Let's dive right into it, and we have left off with our random Pokemon picker for the last time. Let's delete the whole view for now and implement our first list view. And it is as simple as saying list. Now list behaves in a way that every view we are putting inside of it, it will interpret as a single row. And so when we say text, for example, and then say Charmander, you can already see we have a list here and Charmander displayed in the first row. Let's run the simulator to have it bigger. In the former days it was called table view, nowadays it's called list, and we have Charmander in the first row. Let's do that for all Pokemons, for Squirtle, Bulbasaur and Pikachu as well. Copy the name from down here up there, like that, and also fix Bulbasaur's name. I'm sorry, I mispronounced him last time. Now run the simulator again and we have all Pokemons in our row. How about we add the type to the Pokemon, right? And if we just say fire for Charmander, we can see that, because I hit resume, we can see that the type, so to say, is in the next row, which we don't want, right? Again, each view in a list is interpreted as a single row. What we can do is we can put all of them into an H stack, into a horizontal stack. And now this whole view is interpreted as a single row, and inside that view we have horizontally stacked the Charmander and fire text. Now when we rerun the simulator, we can also see it over there. It just works. Let's just do that for all the Pokemons. We will have to copy the H stack like this, and Squirtle, Bulbasaur and Pikachu, right? Let's delete them over there and then say it was Squirtle and it has a type water. And then it was, we can also hit resume here so we can preview it live. Then it was Bulbasaur and it was actually grass. And ultimately Pikachu with the type of electric, right? How about we make this even more beautiful with a foreground color of red for fire and blue for water, and green for grass and yellow for electric, like that. Now that looks pretty cool. I mean, I like beautiful UIs. I'm not sure about you, but you will have to do that now. So let's continue. We have our static list. How about we make this list based on an array? Let's go ahead and implement a struct that represents a Pokemon, right? So a Pokemon should have name, type, and color, right? So let's do that. Name of type string, type of type string as well, and color of type color, because color is the type that this function expects to be passed in. Now what we can do is we can actually say this state variable, we can rename that to Pokemon list, and instead of assigning a string, we will actually create an array of Pokemon instances. So Pokemon, and then, yeah, Charmander, fire, and what was it? Red, right? And do all of that for Squirtle, Bulbasaur, and Pikachu again. Now we can just copy and paste that to make this faster, this whole process. You can also skip that if that is boring, but actually, I mean, you will have to do it as well, right? So electric over there, and then like we say blue, we say green, and we say yellow. So what we want to do is we want to have, we also have to fix now this one, because we are assigning a string to our Pokemon variable, which does not exist anymore. It will now complain. We just comment this one out. We will take care of it later. So what we have here is a list of, or an array of Pokemon instances, right? I prefer to delete the last comma. So what we want to do is we want this list to be based on that array and render for each element an H stack with the name, type, and color. So let's delete all of those other H stacks and say, well, list be based on the Pokemon list And now we will have to do an identified by, and this one is telling the list how to identify each row as unique based on either column name or type, basically based on a variable of the instance of the array we are passing in here, right? And then for each Pokemon in that array, we're saying render an H stack with Pokemon.name and then Pokemon.type and ultimately Pokemon.color. Now, when we run this simulator, we will see that everything still looks the same because it still works. We're rendering for each Pokemon instance the name and the type. Squirtle, Bulbasaur, Grass, Pikachu, Electric. Now, let's break the list a little to understand how important identified by actually is. How about we change the name of the second Pokemon, we're changing the name to Charmander, because right now we're saying, hey, the list is identified by the name, so each row has a unique identifier, which is the name in this case, which suits for this case. But as soon as we say Charmander for the second element as well and run it, then we don't have for each row a unique identifier. And you can see, yeah, Charmander is rendered for the second element, but it also renders fire as a type and red as a color, although this should be actually water and be blue. It's just because the list gets confused. That's why the identified by should be unique and is needed. Let's just revert that. So this is the simple approach how to make a list based off an array. Let's do the more for bigger projects suitable approach by using the identifiable protocol, and we will have to conform to the identifiable for our struct. And this protocol requires you to implement just one variable, and that is an ID. And that ID can be of any type as long as that type is hashable. Now, hashable is like a lot of types are hashable: int, double, string, and so we can choose whatever we want here. I like to go with int, so we can just use numbers, right? 0, 1, 2, 3 for the ID. And we will have to now fix the instantiation of Pokemon because right now we are not considering ID, which it clearly is requiring now, right? So let's say ID 0, 1, 2, and 3, like that. Now, what we gain with that is that we don't have to tell the list anymore how to identify each element because we are conforming to identifiable. Now, when we run the project, it will still look the same, it will still work, but even if we change the name now, right, and run the project again, it works. And the second name is Charmander, but water and blue is displayed because the identifier is the ID instead of the name. Now, we have our list based on an array. How about we are adding a navigation view to our list? So it is actually super simple. Let's cut this one out and say navigation view and put this one inside of here. Run the app. Done. We have a navigation view, but we don't have a navigation title, and there's something like a catch to know about that. So whenever you want to adjust the navigation view, you will have to do that on the first child view of that navigation view. And what I mean by that is we have the navigation view, and the first child view of that navigation view is going to be the one where you want to adjust the navigation view on. So let's say we are having the list as the first child view, and we are calling navigation, for example, navigation bar title on this one, and passing in whatever a text, whatever this navigation view should actually display as a bar navigation bar title. And you can see it works, and even we have the transition to an inline title like that. Now we are applying this function on the first child view of the navigation view. We can go further and now say we want to add a button to our navigation view, right? We can add a button to the leading, trailing, or both sides. Let's add a button to the trailing side and say navigation bar items trailing, and then we are going to use a button, and that button again has an action and label. Let's put it on the next line so it's better, so it's more readable, like this. Is it actually right? I think we're one off like this. Yeah, this is the closing for that, this is the closing for that. So action, we want to have this function to be executed. Let's rename that to add Pokemon, and let's use that add Pokemon function. We will take care of it in a second, as promised. Now label should return a view that represents the appearance of the button, and we just want it to be displayed as a text that says add, just like that. Let's run the app and let's have a look. We have a navigation view, we have a button, and it says add. Now when we click the button, nothing really happens because we haven't implemented anything for the function yet. What we can do is, or what we want to do is actually, we want to say, well, we want to have a random element, or actually random Pokemon, out of the Pokemon list by calling random element. Luckily, this is a native implementation of array provided by Swift that will pick for you a random element out of your array if it's not empty. If it's empty, it will return nil. And now you get why we have to use if let, because that function does not know whether your array that you're using is empty or not, and that's why it's always returning an optional element, and it can be nil. We're handling it with if let, so that code inside here is only executed when we actually get an element back, a Pokemon. So let's just append that random Pokemon to our Pokemon list. So basically we are choosing a random element out of our array and then copying it and then appending it, right? So that's what we're doing here. And again, since this one has an annotation of state in front of it, as soon as this variable is changed, it will re-render the view, and therefore it will iterate through the whole list again with the new list, right, with a new element inside that list, and will display it properly. Now this one just works, adding water, grass, 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 electric, electric, grass again. And there's a small catch here, because this code is not quite production ready, because again, the ID is the identifier, right? The identifiable. Now, when we pick a random element out of this array, we're using the whole element and we are copying it. So we have Charmander, 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 and all of them are having the ID 0. So this one kind of confuses the list and it will lead to bugs. What we can do to fix that is to say, well, we want to have a new ID, and how do we get the new ID? We want to have it actually continue the numbers, right? How many elements do we have in that array? 1, 2, 3, 4. What is the next number we want? 4. So we can actually use count, and we can use it forever, because Pokemon list.count will return 4 when we click that, right, for the first one. And we cannot, let's say Pokemon list, not random Pokemon, Pokemon list like that, count. And once we click that, we have 1, 2, 3, 4 elements. So it says 4. New ID is 4. Then we can say random Pokemon, its ID is the new ID. And we will have to make this a variable to be able to do that. And then we are adding the random element. Then we have 5 elements. And we also have to make this one a var. Now when we add another Pokemon, our count returns 5, right? And then we're assigning 5 as a new element, ID. And then we're adding a new element again. And then we have 6 elements and so on. So we can always use count, and it always works. Now let's just run ultimately our app and see whether it plays out as expected. And we can just add pretty random elements to our list and scroll through them. And that's the episode. I hope you've learned at least one thing. If so, you can help me out by hitting like. Also, hit subscribe if you don't want to miss out on future episodes on state, list, bindable, and all the SwiftUI topics. Leave a comment if you have any thoughts, idea, or feedback for future episodes. I'm happy to answer all of your comments. Check out the description box for my merch to support me doing YouTube full-time. Also to check out my Patreon to, again, support me doing YouTube full-time. I hope I see you in the next one. Bye.